Ugh, finally. Perfect. This is just what I need. Okay. Okay. Oh. Ah! You're back. I didn't hear you come in. I wasn't researching. I know what I'm doing. I know exactly what I'm doing. Don't worry. We got this. Alright, plan for this video is to design, fabricate, and install our own power steering assembly for that go-kart frame. We're going to be using this 12-volt automotive windshield wiper motor for power. If you're not familiar with this assembly, this is a automotive windshield wiper transmission. In addition to stealing the motor, we are also going to steal all the ball joints from this because I want to use those over in our steering rack. Let's get started. Oh, and don't tell the wife that I used our good chopsticks for this. She would not be impressed. First thing we're going to need to build are our two custom steering arms. These are going to get welded to the front of each fork, and then all the steering geometry gets built on top of that, so that way the two front wheels move together when we turn. Nicest spot to build them is right here on the front of each fork. We've got a really nice smooth lip, 90-degree surface on the top, and we can just slot our steering arm right in there and then weld it up. So first thing I'm doing is I'm setting up my stock. I've got some 40 mil flat bar that's like 1.5 inches. This is steel. And then I'm setting up a center line just so I can reference it throughout the build. First point I'm marking is this is a drill hole for that ball bearing that'll go on the very front, and everything kind of articulate off of that. And I'm leaving myself a 4 mil buffer around there. The second larger hole is for where it'll actually mate up to the go-kart frame, and I'm setting myself a 70 mil space between both centers. I'll talk more about that once the thing's actually built, because it'll make more sense then. Once again, I'm setting a buffer around that. That's that larger circle, just so that way I know that I've got some metal to work with and to kind of weld on. Then I'm just articulating some lines between the two, so that way it looks kind of pretty. And I'm mirroring that from the top down to the bottom. And then I'm mirroring everything from the left side over the right side, because I'm already drilling with the one big hole in the middle. So I might as well make both steering arms at the same time with the one drill. Selecting all my components. And then once I know I've got everything, extruding it to my stock width, which is 3 mil. And here we are. We've got both steering arms ready. Now it's time to transfer them to the steel since we like that design. You ever wonder how ClickSpring does stuff so neat? I wonder. Doesn't keep me up at night or anything. Definitely doesn't keep me up all night.
I call your name, but you're not there. Was I to blame for being unfair? Don't you know I can't sleep at night since you've been gone? Well, I never weep at night. I can go on. Don't you know I can't take it? I don't know who can. Well, I'm not gonna fake it. I'm not that kind of man. Oh, I can't sleep at night, but just the same, I never weep at night. I call your name.
Alright, both steering arms are done and dusted. Before we can weld these into place, we need to go over Ackermann steering so that way we know exactly what angle to weld these at. So when people talk about Ackermann steering, they're talking about the front steering arms and how that relates to tire angle. If we were to turn both front tires the same number of degrees, we would end up with two converging circles when we turn, and this would create scrubbing or scraping as the tires tried to run into each other. To avoid that, we need the inside tire to turn more than the outside tire, so we end up with two concentric circles when we turn. Hopefully the front left tire won't fall off. It's catching up! Go, buddy, go! Go! Yeah, it made it. If you want a good approximation of the angle for your steering arms, just draw a line from the middle of the back axle up through the pivot point for the front tires. From there, take this steering arm and then lay it over that line so that way the line's bisecting your steering arm. So for a forward steer, steering arms will stick out. If it's a rear steer, so the steering arms go behind the front tires, then they'll point in toward the back axle. If I were to make an actual model of this setup, it would look like this. And you can see that when we go full lock, we have 40-degree turn on the inside and a 32-degree turn on the outside. Same thing the other way, 40 inside, 33 outside. If you want a detailed Ackermann video, click the link. I'll put it up once I've made it. I'll give you all the math and geometry that are involved in this, exactly how to apply it to your project. I'll also make a few more models for it so that way you can see exactly how everything works together. Check it out. Thankfully, this is pretty easy to implement on our project. I've already got the all thread going through the back axle, so I've divided that in half and then tied string up through the center of each fork. After I put the string through the center of each fork, I held it in place with these plugs that were part of the original scooter. And then I copied this angle just straight up toward the ring that we're actually welding our steering arm to.
I call your name, don't you know I can't take it? I don't know who can. Well, I'm not gonna fake it. I'm not that kind of man.
Alright, steering arms are done. It is thankfully time to disassemble this and desperately hope that I don't need to film it anymore. I'm sure though as soon as I'm done, I'll be like, oh yeah, if only I'd filmed that. That would be perfect. But I won't have it anymore and it'll be a shame. Ball joints. Plan is to take both the steel bit and then these plastic caps here, and all of these are going to go into our focus. There we go. All these will go into our scooter. I only have as many of these, or exactly the number of these that I need, so I need to not break any of these when I pull them out. Here's the setup. We've got the female ends of these ball joints, which appear to be plastic, and they're pressed into the metal. Now, I've never dealt with these before. I don't know how to get them out, but the plan is to put a socket over this end, which fits just around the plastic face. Then we've got a punch socket here, which cups over the end of that dome, like so. And hopefully we'll just end up pressing the plastic back through without crushing anything. Oh, it's getting tight. Oh, ooh. I do not like the look of this. Let's give it one more little push. Oh, I can't tell. Let's pull it back. We'll see what we have so far. Let's see. We deformed the top. Yeah, so we put indents in the top. And we got almost nothing back here. All right. Strategy number 2. So punching it out didn't work. Attempt number 2, we're just going to wiggle it and see if we can just break off the end of this metal. I'm not too inclined to take the angle grinder to it just yet. Wiggle, 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 wiggle. Wiggle. Oh, it's getting loose feeling. Yeah, there it is. Focus. Focus. There we go. My goodness, there we go. All right, so that wasn't too bad. That's about 10 seconds per. And there we have it. So they do have a little retaining ring there. Should be able to press them out, I would think, if we can not deform the lid. But it looks like I can also get these back into a circle that I drill, which is promising. All right, 1 down, 3 to go. Yeah. Oh. I should not be wearing long sleeves right now. Perfect. Perfect. Next up is to grind all the balls out. It appears that they're just pressed in, so we're going to grind back here, then hopefully they'll fall out the front. Let's see what happens. Grinding, grinding noises. That does not appear to be pressed in the way that I'd hoped. Well, there's a little bit of a ring there. Just a little bit. You see it there? Let's keep going. We'll see. We'll see what we can do.
Name, don't you know I can't take it? I don't know who can. Well, I'm not gonna fake it. I'm not that kind of man. No, I can't sleep at night. But just the same, I never weep at night.
Next thing we need to do is connect this one to the other one. We'll just use this flat stock. We're going to use the hole on the underside as a pilot hole and then drill straight up through the top. Let's mark out a center line and then drill from there. So mark the center line, and I'm just using the scribe to find it, poking it up through the holes that we pre-drilled in our steering arms. Now I flipped it over and I'm using the holes from the steering arm as a guide. After this, we're going to disassemble, then drill all the holes to final dimensions so we can put in the stuff from the wiper rack.
I call your name. I call your name. I call your name. I call your name.
It's dead, Billy, it's dead! Oh, sweet Jesus, let it rest in peace! So, turns out that these bearings actually are press fit. I was grinding this thing and this little outer sleeve started to spin. So we'll see if I can pull it off. There we go. So yeah, built pretty much how I thought. It's got a little shoulder, so that way it would just sit in, and then they press out the bottom. Here's that little sleeve. So I don't know whether they were heat shrunk on, and that's why I had a hard time telling a difference or punching it out. Maybe I didn't try hard enough. If I were going to do it again, I'd come in with the angle grinder from each side, and then hopefully that sleeve would just fall off. Now we know. And here's that bearing going into the end of the steering arm. Sit right like that. I'll weld it up from the bottom. We can install our steering rack, and then we are done. Alright, we have made it. Everything is done. Now it is time to put our steering arm on. I will clean up these edges and make it prettier. I just want to make sure that the geometry is alright. So, see if we can pinch this together. Alright, try to pinch it together. Yeah, that's one. Number 2. Oh, yeah. Oh, feels good to me. Alright, there we have it. Steering arm is done. I'll clean up these edges, and then probably make that a bit thinner, put a supporting bar across the top, and then the next thing we'll have to do is connect this up to the motor, which will live back here. But we're at least done with this part. What was that? Oh, you want me to take off the stand now? Oh, you actually want me to put wheels on it. You want to see it turn. Okay. We're off the stand. It is starting to look like a go-kart, and I am excited. For steering, we can go to a full right-hand lock over to a full left-hand lock. It's pretty easy to turn this, well within the bounds of the wiper motor, so we're looking good so far. As far as Ackermann, we're looking pretty good. You can see the inside wheel turns quite a bit more than the outside wheel. I did take this for a push around outside, and it seems to be pretty correct. I did tell you earlier in the video I'd explain why I chose 70 mil for these arm lengths. First reason is so that way the arms stayed well behind the front tire. That way if my son crashes into something, he doesn't hit this, it hopefully just squishes into the rubber. Second reason is that even minor differences in the arm length make big differences in the overall travel of the steering rack. We need to stay within the arm length from one direction on this motor to 180 degrees the other way. If you haven't guessed by now, we are calling it for this video. We're over 10 minutes long and we've had 2 montages. Enough is enough. In part number 2, we are going to install the steering motor. Fabricate a bar that connects this to this so that way they turn together. I will also mock up all the electronics so that way you can see it turn by me turning a potentiometer. Keep an eye out for that. Questions, comments, feedback, stick them down below. I'd like to hear from you. Otherwise, I will catch you guys next time. Thanks for sticking around.